Hello everybody and welcome to Campus 101 exam curriculum series. My name is Dr. Piro and today we're going to be looking at allotropy. Allotropy is simple, but it comes down frequently in your exams. If you do not know allotropy, you are going to be losing cheap marks in your exam, alright? So in the past 10 years, I think I've seen it 3 times out of 10 times in your exam. So it has a 30% chance of coming out. That's fair enough if you ask me. So what is allotropy? Now first off, let me say allotropy is not isotopy. It is not isotopy. It is not isotopy. Isotopy is a different property altogether. Today we're going to be looking at allotropy. Allotropy is the existence of elements in different physical states. What this means is that these elements are still whatever they are. However, the physical state of the elements is different. I'm not talking about solid, liquid, and gas per se now as the states of matter. I'm talking about in room temperature. For example, water exists as in room temperature as liquid. When we increase the temperature, it becomes gas, and then when we decrease the temperature significantly, it becomes a solid. But there are some elements, and now water has gone back, but there are some elements that in room temperature, in the same conditions, they can exist, all right, in 2 different physical forms. Chemical properties are still the same, but in physical properties, they are different. 2 very important elements on the periodic table that show allotropy are carbon and sulfur. So let's start with carbon. I'm going to be writing in black here. Carbon has 3 isotopes. The first one is coke or coal. And we're going to be, if you have not looked at the video on gaseous fuels, you should take a look at it because we talked a little about coke there. Alright, so coke is 1 isotope of carbon, of 1 allotrope of carbon. The next one we're going to be looking at is graphite. Alright, graphite. The next one we're going to be looking at after graphite is what? It's diamond. It's diamond. Alright, so these are all allotropes of carbon. The reason why they exist in different physical states is because the composition, the arrangement of the atoms in the structure of these elements are different. In coke or coal, the structure of the atom, of the carbon atom, is random, is disorganized. That's why we can have a piece of charcoal that has a crazy shape. Alright, and then it is still carbon. It is still carbon. Alright, it's still element 6 on the periodic table. When you present this on the periodic table, you still call it carbon. Alright, you understand? The same number of protons, the same number of electrons, but physically is existing as an amorphous. An amorphous means shapeless. A shapeless solid. Alright, now when we increase the arrangement of, when we increase the order of the arrangement, we get graphite. Graphites are shiny in nature. They are transparent, translucent, transparent. Now, but in graphite, the atoms in graphite are arranged in a very interesting way. They are arranged in hexagonal patterns. Alright, so they exist in hexagonal patterns. Alright, and then they exist in layers. Alright, so graphite therefore has a better structure and it's even more beautiful when you look at it physically than carbon. So it's no longer an amorphous compound. It's now this is important right now. It's now a hexagonal pattern in the arrangement of the carbon atom. Alright, and then it's no longer amorphous, but it's crystalline. It's crystalline. So graphite. Alright, now the next we're going to be looking at is diamond. Diamond has the best arrangement compressed, right, structure in the atom. Coal is used as fuel. Graphite is used as a lubricant. Also, when you mix lead, the element lead, with graphite, you can also use it in pencils. All right. Now, diamond is beautiful. It is used is a jewel. All right. So jewelry. All right. It is also used as a cutting tool. You know, the hardest substance on earth is what? Is diamond. Telling you the importance of packing it so well in the structure of this compound. The next compound we're going to be looking at, which also exhibits allotropy, is sulfur. There are two main allotropes of sulfur, two major allotropes of sulfur. The first one is called the orthorhombic sulfur. And then the second sulfur is called what? The monoclinic sulfur. Alright, so orthorhombic and monoclinic sulfur. Orthorhombic sulfur is also called alpha sulfur, and this is also called beta sulfur. Alright, so monoclinic sulfur is of less value. It is yellowish, it is solid or powder. Powders are solids after all. Alright, so yellowish powdery substance. Alright, and then orthorhombic sulfur is crystalline. It's crystalline. Now, it is important to note this because it has been so frequent, alright, in your exam. Now, what are the uses of sulfur? Now, for those of you that will read organic chemistry well enough, you discover that sulfur is used in what? Vulcanization of rubber. Vulcanization of rubber. Both of them using vulcanization of rubber. It's also used in insecticide. It's also used in creams, right? So ointments. Some ointments have sulfur. So these are the uses. So these are some of the uses of sulfur. So once again, I'm going to take it from the top now. All right. So what is allotropy? Is the existence of elements in different physical states. Two major allotropic elements are carbon and sulfur. The allotropes of carbon include coke, graphite, and diamond. Coke is used as a fuel. It has an amorphous structure. Graphite is used as a lubricant and it has its hexagonal crystalline structure. Diamond is a jewelry. It's used as a cutting tool and it has an octahedral structure. Sulfur has two major types of allotropes: orthorhombic sulfur and monoclinic sulfur, also called alpha and beta sulfur respectively. We also looked at the uses of sulfur, which include vulcanization of rubber, use of insecticide, and the uses as cream. So this will complete our discussion on allotropy. We'll see you in the other videos.